So, part 2 of solving quadratic equations. Here we're going to look at, start with a very simple one. Now, you need to remember that x is equal to 3, but it's also equal to minus 3, because minus 3 times minus 3 makes 9. And that gives me my two solutions. Now, we talked about that in part 1, so hopefully that's something you're still aware of. Let's look at another equation. Now, you're going to think this is much more difficult. You're going to think, well, in part 1, you taught us that when we have a quadratic equation, we can factorise it if it's equal to 0, and then we can solve it. This is not that situation yet. In fact, it's nothing like it. And some of you will want to expand this bracket, try and make it equal to 0, and then try and factorise it. Now, we're not going to do that. We're going to do this. Something squared equals 9. So look up here. Whatever's under my finger should equal plus or minus 3. Okay, so it's x plus 1. So I better write that as x plus 1 equals 3, or x plus 1 equals minus 3. Well, that means x is 2 over here, and over here it will be minus 4. So two solutions available from that situation. I've solved a quadratic equation without anything more than remembering that x squared equals 9 gives me x equals plus or minus 3. Okay? Let's take this one. Well, look how tricky that is. It's got fractions, it's got extra terms. Hang on a second. Something squared equals 25. So that's plus or minus 5. Okay, so 2x minus 1 over 3 equals 5. So let's separate it into equals 5 and equals minus 5. And to solve both of these, we'll do the same steps. We'll multiply by 3, add 1, and then halve it. So, same over here. Watch you don't put minus 16, adding 1 to minus 15. And there's your two solutions. Now, this all seems rather convenient, and it relies on this principle that you've got something squared. So what you're saying to me now is, it might not be that common to be given it in this format. It might be more likely that I get something like this, and I have to make it equal to 0, then factorise and then solve. And that's true. But actually, what we've done here is going to lead in really nicely to the trickier ones to come. And we're going to use this kind of method because actually it appears to me if I can get a quadratic equation into this format, I can always solve it. I wonder if I can always get a quadratic equation into that format. Well, let's have a look at that, shall we? Let's take the general quadratic equation and try and make it into something like that. Here is the general quadratic expression. Now, to make things easier, I'm going to put it equal to 0 to start with. If this wasn't 0, if this was another number, or even an x, we would take it off and it would change c if it was a number, or it would change b if it was an x. So let's assume we've already got it to this stage. Okay. Now what we're looking for, down here somewhere, let's presume there'll be a few steps, is something squared equals something. So how do I write this as something squared? Okay, I'm going to rule off this side margin and do some calculations. So, if I had x plus 1 all squared in a bracket, that would be x plus 1 times x plus 1, which is going to give me x squared plus 2x plus 1. If I had x plus 2 all squared, that's x plus 2 times x plus 2. So that's going to give me x squared plus 4x plus 4. The next one gives me x squared plus 6x plus 9. How did I get that so fast? What am I spotting? So this number appears to be double the number on the end. And this number appears to be the square of it. Well, let's check and do it carefully. So, x plus a, the whole first bracket, times by x, and then the whole first bracket times by a. X times x is x squared, a times x times a, so I'll write ax again, and then a squared. Well, that's x squared, and that's a squared, and that's 2a lots of x. So the number on the end is double here, and the number on the end is squared here. Now, this has worked if we only start with x squared. So let's try and use that. Well, I'm going to try and get rid of this a then. How can I get rid of that a? Well, if I don't want 2 lots of x squared, I would divide by 2 to get x squared. So if I don't want a lots of x squared, I'm going to divide by a. That leaves me x squared. It leaves me this thing divided by a. This term divided by a. And this term, curiously, stays as 0. Now why is that? Oh right, because 0 divided by something will still leave you 0. Okay. So now here we go. I've now got an x squared term just like in my example. Let's copy that formula down underneath. X squared plus 2ax plus a squared. So, I'm going to open up a bracket now and try and do this. So I'll put x here. I'm then going to put plus. Now, I need 2 lots. This term here is 2 lots of what goes in the bracket. 2a gives you a in the bracket. So what starts here may be 10, and what goes in the bracket is 5. What starts here may be 20, so what goes in the bracket is 10. So the bracket contains half of this term. So half of this is that. Then it becomes the bracket squared. Okay. Now, just doing some working out then. X plus b over 2a squared. Well, I know it's going to give me x squared, and I know it's going to give me b over a lots of x. What does it give me here? It gives me the term on the end squared. So it gives me b over 2a squared. But look at what I had. I didn't have b over 2a squared. So this bracket is going to create a term that I don't want. So I know that I've put these two here to get the x squared and to get this. And I've accidentally created the last number to be wrong. So I'm going to take that number off. Now, these two terms here are the same as all of this, because this bracket gives me x squared, it gives me this, and this bit squared cancels out here. But I don't have this, so I'm going to have to add that on the end. And that's still all equal to 0. Now getting this into a bracket has been really fiddly then, because if this had been 6, I'd have put 3 here. Let's do an example with numbers to help you. Let's try and put this into a bracket squared like we've just done there. I'd open the bracket and go, this is 2a and I want a. So this has to be 3 squared. Done. But hang on, the last number is supposed to be the thing squared and it's not. Well, 3 squared is 9, I want 10. So in this case I put just a +1 on the end. So what goes outside the bracket here has to make this expansion fit this. And here, of course, because we had a more complicated bit of algebra, that proved quite tricky. Well done if you're keeping up so far. This is not an easy video. So, now we've got bracket squared, which we wanted, and then these two things, and then equal to 0. Now, A, B and C are just any numbers. So this whole thing here is just numbers. So what I want to do is get the bracket that's here and make it equal to whatever it takes to get this stuff gone from here. So to get rid of this one, I'd have to add this to both sides. And to get rid of this one, I'd have to take it from both sides. So I get this. Now, in order to, now I've got things squared equals stuff. Let's tidy this up so that we can do this easier. And remember, what we're trying to do here is take any quadratic and see if we can solve it. So this bracket expands to b squared over 4a squared. Take away c over a. Okay, now, in order to combine these two, we need to make their denominators the same. So I'm going to keep that one as it is and change this one into 4a squared. And the reason I'm doing that is a goes into this. All I need here is to times it by another a and by 4. So I times the numerator by another a and 4 and leave the c there. And we're starting to get somewhere. We're moving towards it. Now I do the subtract, even though I can't work it out, to get one thing. And now I've got bracket squared equals thing. This is going really well now. So I'm now going to do what we did previously. Let's look back quickly. You've come a long way. Something squared equals a number. So we do the thing inside the bracket equals plus or minus the square root. So something squared equals a number. So we do the number equals plus or minus the square root. Oh, it looks horrible, doesn't it? Do not worry. It's all going to become beautiful in a second. I'm going to move this way and write bigger to give you more chance to see. And if you've done this topic before, right now you should really start to go, aha, I can spot where he's going. Now, I want to know what x is, so I'm going to take this thing off. I'm going to put it at the front, like this, and then put the plus or minus. Now, this bottom here is 2a times 2a. So we can actually square root the bottom. I'll leave the top as it sits, because we can't work that out. And now I'm going to go for one last step. And then what we've got, remember we started with any old quadratic. And we use the fact that something squared equals a number we can solve. And what we've now got is a formula for any old quadratic, where as long as we know A, B and C, we can put them in here and work out the value. Now you may want to pause and go through that again, or some of it again. In the next video we're going to use this formula. And in the video following that, I'm going to talk to you a lot more about this process of taking the brackets and putting them into something squared, or what we call completing the square, which we used here. Well done for following though, that's a very tough video.